Newton's second law of motion. We will investigate the relationship between mass, force, and acceleration on a moving object. To do this experiment, we will need a dynamics trolley, a rail track, a ticker timer, ticker tape, a measuring tape, cotton thread, 12-volt battery, carbon paper, set of mass pieces which are 100 grams each, and a pulley. To do this experiment, we will set up a rail on a level table, attach a pulley to one end of the track, insert the ticker timer to the other end of the track, place a circular piece of carbon paper in place on the ticker timer, place a trolley of 1 kilogram onto the track. Measure a length of ticker tape equal to the length of the rail track. Feed the tape underneath the carbon paper on the ticker timer. Using lead wires, connect the timer to a 12-volt battery, making sure that the polarity is correctly connected. To the front end of the trolley, attach a thread of cotton and feed it over the pulley. With the trolley at the ticker timer end of the rail and the thread of the cotton over the pulley, attach a mass of 100 grams to the end of the cotton. 100 gram mass produces a force of 1 Newton. Switch on the timer and let the trolley run the length of the rail track. Remove the tape and let this be called M1F1. Keeping the mass of the trolley constant, repeat this procedure another 3 times, changing the force on the thread to 2N, 3N, and 4N. These tapes will be called M1F2, M1F3, and M1F4. A further 4 tapes will now be prepared when keeping the force constant at 2N but changing the mass of the trolley by adding mass pieces of 1 kilogram each to the trolley. This will result in having 4 more tapes as follows: M1F2, M2F2, M3F2, and M4F2. The acceleration which is produced in each tape is now calculated. Taking the first tape, mark off every 10th dot on the tape. The distance between the start and the 10th dot gives the displacement in a quarter of a second. The next 10 dots give the next displacement in a quarter of a second. It is now possible to find the velocity of the trolley for each section on the tape. The difference between the first velocity and the last velocity on the tape divided by the time it has taken to reach this velocity will result in the acceleration of the trolley for those conditions of force and mass. When the force is constant, we draw a graph of mass versus acceleration. When the mass is constant, we draw a graph of force versus acceleration. This presentation was brought to you by the Cape Town Science Centre, made possible by the sponsorship of the Western Cape Education Department.